So we have discussed in the last lecture up to continuous population model. So now we discuss what is exponential growth. So if a population has a constant birth rate through time, is never limited by food or disease, it has what is known as exponential growth. With exponential growth, the birth rate alone controls how fast or slow the population grows. So if we uh, take that dndt, that is the growth of a population whose density is n at a time t greater than 0 is equal to Rn, that is as Malthus law, dndt proportional to n. So we take equal to R into n, and from this we can find n as a function of t equal to n0 into e to the power r into t. So n0 is the population density at t greater than 0. So from this we get the population nt tends to infinity as r greater than zeros, and nt tends to 0 as r less than 0, and nt constant tends to a constant when r equal to 0. So here r is a vital parameter that is called intrinsic growth rate. Intrinsic growth rate, that is birth minus death of the population, it is called intrinsic growth rate. So this is the exponential growth of the population with density n. So now exponential population growth model. Exponential population growth occurs when a single species is not limited by other species, no predation, parasitism, competition, resources are not limited, and environmental conditions are constant. In such conditions, population grows exponentially at constant percentage per time. Such a condition that permits exponential growth of a population is called ecological vacuum. Ecological vacuum does not often occur in nature for a large period. In nature, exponential population growth occurs commonly during a recovery of a population after a large-scale disturbances. And now the logistic population model. The differential equation of the logistic population model is denoted by x dot equal to rx 1 minus x by k. Here r is the intrinsic growth rate. Intrinsic growth rate. X is the density of the population, and capital K is the carrying capacity. Carrying capacity of the population. Carrying capacity is a property of the environment where populations exist. So we will discuss later what is carrying capacity. And now harvesting in population model. So let a population model is defined by the differential equation x dot equal to f of x. Then the population, if the population is removed or harvested in a specific rate ht per unit time, then the population model change to x dot equal to fx minus ht. So this differential equation known as harvesting population model. So constant yield harvesting, when we harvested the population at a constant rate, that is when ht equal to as a constant, then the population model becomes constant yield harvesting population model, that is this ht becomes h, so equation becomes like this: constant effort harvesting, so effort become constant, that is ht now becomes e into xt. Here e is a linear function of population size, that is called harvesting rate, and then the model become like this type of harvesting is called population proportional or constant effort harvesting. So after uh, that we will discuss about discrete population model. So